Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 68. So to start, I'm going to first rewrite 8 here as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 68. And I can actually switch the places of the 3 and the x. So this is the same thing as 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 68. Now, I'm going to let 2 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 68. And if I subtract 68 on both sides, I get y to the power of 3 plus y minus 68 is equal to 0. Now, 68 I can rewrite as negative 64 minus 4. And now I'm going to change the order to y to the power of 3 minus 64 plus y minus 4 is equal to 0. Now 64 is the same thing as 4 to the power of 3. So I have y to the power of 3 minus 4 to the power of 3 plus y minus 4 is equal to 0. And if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this is going to equal y minus 4 times y squared plus 16 plus 4y plus y minus 4. And now if I factor out y minus 4, I get y minus 4 times y squared plus 16 plus 4y plus 1. And this is equal to y minus 4 times y squared plus 4y plus 17 is equal to 0. So now this gives me two equations. I have y minus 4 equals 0, meaning y equals 4, and I also have y squared plus 4y plus 17 is equal to 0. And if you end up using the quadratic formula in solving this, you get the square root of a negative number, and you can't take the square root of a negative number, so this is wrong, and y equals 4 is my only solution. Now remember how we let 2 to the power of x equal y. So now we have 2 to the power of x is equal to 4, and 2 to the power of what equals 4? 2. So I get x is equal to 2, and this is my solution. Alright, so in this problem, I have x to the power of x is equal to 4 to the power of x plus 16. So to solve this, I'm going to first start by taking the natural log, or ln, on both sides. So now I have ln of x to the power of x is equal to ln of 4 to the power of x plus 16. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front. So now I have b times ln a. So in this case, I have ln x to the power of x, and I can move x to the front. And for here, ln 4 to the power of x plus 16, I can move x plus 16 to the front. So now I have x times ln x is equal to x plus 16 times ln 4. Now if I distribute the ln 4, I get x times ln x is equal to x ln 4 plus 16 times ln 4. Now I'm going to subtract x ln 4, so now I have x ln x minus x ln 4 is equal to 16 ln 4. And now if I factor out x from here, I get x times ln x minus ln 4 is equal to 16 times ln 4. Now ln x minus ln 4, that's the same thing as ln of x over 4. And now if I divide both sides by 4, I get x over 4 times ln x over 4 is equal to 4 times ln 4. And notice how I have something in the form something times ln of that same thing is equal to 4 times ln of 4, meaning x over 4 is equal to 4 and x is equal to 16. So now to check, my original equation was x to the power of x is equal to 4 to the power of x plus 16. So if x equals 16, I have 16 to the power of 16 is equal to 4 to the power of 32. This is the same thing as 2 to the power of 4 to the power of 16 is equal to 2 squared to the power of 32, which is 2 to the power of 64 is equal to 2 to the power of 64. Alright, so in this problem, I have x to the power of 2 over 3 is equal to 16. So for my solution, I'm going to first start by taking the power of 3 over 2 on both sides. So now I have x to the power of 2 over 3 to the power of 3 over 2 is equal to 16 to the power of 3 over 2. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So x to the power of 2 over 3 to the power of 3 over 2, that's going to equal x to the power of 2 over 3 times 3 over 2. And 2 over 3 and 3 over 2, these two are actually reciprocals, and meaning that the numerator and the denominator are switched. So if you multiply two reciprocals, you actually get 1, always. And over here we have 2 times 3, which is 6, over 3 times 2, which is 6, which is equal to 1. So I'm left with x is equal to 16 to the power of 3 over 2. Now 16 to the power of 3 over 2, this is the same thing as I'm going to replace 16 with 2 to the power of 4. So I have 2 to the power of 4 to the power of 3 over 2. And remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 4 to the power of 3 over 2, that's going to equal 2 to the power of 4 times 3 over 2, which is equal to 4 times 3 is 12, 12 divided by 2 is 6, so 2 to the power of 6. So I have x is equal to 2 to the power of 6, and 2 to the power of 6, that's going to equal 64. So I have x is equal to 64. So now to check, I had x to the power of 2 over 3 equals 16. So now I have 64 to the power of 2 over 3 is equal to 16. And 64 is the same thing as 2 to the power of 6. So I have 2 to the power of 6 to the power of 2 over 3 is equal to 16, which is the same thing as 2 to the power of 6 times 2 over 3, which is 4, is equal to 16. And 2 to the power of 4 is 16. So I have 16 is equal to 16, and this is right.